Hi, my name is Will, and I'm with Joey, and we are group number 2. Today we will teach you about even and odd functions. Starting with even functions. Even functions are symmetric about the y-axis, as you can see in the cosine graph.
Odd functions are symmetric about the origin. A good example of this is the sine function. Now let's practice with Will. Imagine his body is the y-axis, and his arms are the function. Guess if the function is even or odd. This is a parabola. This is x cubed. This is x to the 1/3. This is absolute value. And this is a straight line. Now the answers were, this is an even function. X to the 3rd is odd. X to the 1/3 is also odd. Absolute value is even, and a straight line is odd.
Alright, so let's move on to equations. To figure out if a function is even, f of x must be equal to f of negative x. When negative x is put in place of f of x, negative x squared ends up equal to x squared.
Now to odd functions. To find if f of x is an odd function, it must follow the rule f of negative x equals negative f of x, which means an opposite input will result in an opposite end value. An example is shown, f of x equals x cubed, and inputting negative x results in the output of negative x cubed. Now back to Will for combining even and odd functions.
Here are some formulas to know whether your graph will be even or odd. When two even functions are added, an even function will be the result. When two odds are added, an odd will be the result. When two odds are multiplied, an even function will be the result. An even times an odd equals an odd, an even plus an odd equals neither, and an even times an even equals even.
Here we have 3 examples of multiplying and adding even and odd functions. Starting with f of x equals cosine x plus x to the 4th, we have 2 even functions being added together. Inputting negative x results in the same even function of after cosine of negative x plus negative x to the 4th equals cosine of x plus x to the 4th. Verifying that adding 2 even functions makes another even function. Our next example multiplies 2 odd functions, where f of x equals x to the 3rd times x to the 1/3. We heard from Will that this will result in another even function. And we can see here that inputting f of negative x equals negative x to the 3rd times negative x to the 1/3. The negatives will cancel out, resulting in x to the 10/3. Finally, we have a function adding an even and odd together. F of x equals x squared plus sine of x. Now f of negative x equals x squared minus sine of x, which transforms the graph so that it's not symmetrical over any point at f of negative x equals x squared minus sine of x.
As you can see in the graph, this function, the first function, is even, the second function is even, and the third function is neither even nor odd. This is because of the formulas that we showed you earlier. This has been a lesson by Will and Joey. Thank you for watching.